So, in a data center, remember data center, if you don't understand what the BMS is telling you, you're basically blind. So, what is a BMS? A BMS is the building management system. The building management system is what we as building engineers use to monitor and control all the mechanical systems, the cooling systems, pressure, temperature, every single thing that could be measured inside of a data center is included inside of the BMS. So, how does a BMS work? It's very simple. You have sensors out in the field right here. The sensors are connected through wires that lead into a control box. It's usually called a PLC, logic controller, PLC. And this PLC has a bunch of, like sensors and stuff, right? And it sends data out into the BMS where it shows you, it has like a UI basically, where it shows you this is my equipment right here, these are the sensors that I have on the equipment or on something, and these are the values that it's showing me. So the sensor out in the field sends data into the BMS shows you what the heck's going on, and from the BMS, you can control what output you want from the data center. So, what are the key spots that the BMS covers? As I said, it covers literally everything in the freaking data center except the people like walking around and stuff. But I'm sure it could do that if it was configured too. What a BMS mainly shows is power, how much power you're having in the data center, the cooling, what's your cooling capacity in the data center, the temperature of the data center, the humidity of the data center, fire systems and like emergency systems, stuff like that, pressures of all the different equipment that are in the data center, flows, which is usually from the chilled water coming from the chillers, and set points. So we're gonna go through these very, very simply. Power. In my data center, it's a 90 megawatt data center. This is a lot of power, a lot of power. So I monitor this and see if my trending line is going like this is 90 megawatts and then it drops to like 50, that's no bueno, right? I'm gonna ask myself, what the heck happened here? And then I'm gonna go out into the physical world with all of my freaking building engineers and see what the heck's going on. Remember, we monitor, we maintain, but we also respond. Cooling as well. On a BMS, you're gonna have, like let's say your data center is set at like 90 degrees. The BMS is gonna check all the sensors out in the field. If the data center says, yep, I'm 90 degrees, it's gonna be like, yep, I am 90 degrees. And the cooling is usually supplied using air conditioning. Air conditioning can come through different forms, which is like chillers, air conditioning units, cooling towers, whatever. Just depends on how big the data center is. A smaller data center will have smaller cooling. Bigger data centers will have more industrial sort of cooling. Humidity is also a big thing that the BMS checks because humidity is what determines if the the servers and the chips themselves are safe inside of the data center. Other than the cooling, of course, and the power, those are like no-brainers. Humidity is a big one because if you're too low on humidity, there is static electricity that builds up, and you could touch a piece of equipment and blow something up. We don't want that, right? If the humidity is too high, what happens is that water droplets form on the equipment, which could lead into like what those water droplets dropping into sensitive equipment, which we don't want that. So the BMS monitors that as well. It monitors the fire systems just in case a fire shows up somewhere. It monitors pressures, usually from the chillers or the air conditioning systems if you're using chilled water. Measures, the pressures of what the heck is going on. So there's this thing called a pressure differential. We'll go into this later, but basically, how an air conditioning unit works is that this is the air conditioning unit, and this is the load side of the air conditioning unit. What happens, this is a supply line. Let's say this is water going into like the data center, right? And then there's a return line, right? Okay, my mic died. I was rudely interrupted, but what we were saying is an air conditioning unit, it's a chilled water system, right? It has a supply sending cold water into the data center and then hot water outside of the data center so that it gets cooled, right? But the air conditioning unit right here, you have to have a differential, a difference in the pressures over here of the flow. Let's say the difference, this is like what, 90 flow, and this is like 70 flow. The difference is 20. That tells you that we actually have water flowing. That's pressure differential right there, right? As I said right here, flows as well, and then set points. Set points, so the BMS can be an automatic system, right? So set points is what you set on the BMS, and you tell it, hey BMS, I want my temperature for my data center to be 90 degrees. If it goes over 90 degrees, let's say it goes to 93 degrees, sends a message out to the logic controller. The logic controller asks, yo, sensor, what are you reading? 92 degrees. And then the logic controller is like, I bet we got freaking rules from the BMS telling us we need to be 90. Okay, then PLC sends a freaking command to like a chiller. The chiller starts running, water freaking the water, chilled water gets cold, the data center drops to 91, then 90 degrees. After that happens, we've reached a set point, and then the chiller stops right there. And usually they're really good, especially in like a really, really big data center. The set point is always reached, plus or minus, whatever your tolerance is for wherever you're working. That is basically what a BMS does. I'm not looking at one number when I look at my whole BMS. I'm looking at the relationship of all of these numbers, right? Because the real value isn't the number itself, it's how the numbers move over time. Remember when I said if I'm looking for power, if I'm at like 90 megawatts and then I suddenly drop to 50 and then I go back up to 90, I'll ask myself, what the heck happened here, right? And I'll find out what the heck happened here. Because this could easily turn into 90, 90, 90, drop, and then we're at freaking 0 or 50, which is horrible. We don't want that, right? So if my power is good, I know that my cooling's probably going to be all right. Then if my cooling's fine, the temperature of my data center is probably going to be fine. My humidity is probably going to be in check. If there's no fires, I know everything over here is good. If my pressures are good, I know the water is flowing correctly. And, the flow, of course, and my set points are being reached. I know from these set points if they're being reached or not, how healthy my data center is and how reliable we are here. That is what a BMS system is all about. Extremely simple. It's not difficult. If you go really deep into it, the most difficult part gets to when you start talking about PLCs, because, but from here, you're not talking about a building engineer anymore. You're talking about a controls engineer now, because a PLC is a programmable logic controller. I'll talk about this later as well, and this is kind of the field that I'm wanting to get into. But what it does is that it has logic embedded inside of it that tells it, hey, if X has happened or has not happened, then Y happens. If I'm at 92 degrees and my set point is 90 degrees, then I'm going to turn on the chillers until I'm at 90 degrees, then I'm going to turn off the chillers. That's basically what a PLC is. But super simple, what a BMS is, it's your eyes and ears inside of a data center. If anything happens over here, you go out and check it out. You monitor through the BMS, you maintain using preventative maintenance, and then you respond if anything ever happens. And the thing about BMS, right, is trends. So a trend is when I look at all the numbers, they're good, they're good, they're good. I'm tracking, and then it suddenly drops, right? And then it goes good, 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 good. We didn't find anything. I'm tracking more, I'm tracking, and then it drops. That's a trend. And over time, trends show issues. And that's what you want to notice in the BMS, because it might not even be a crazy dip. It might just be a little bit, a little bit, a little bit, a little bit. But if you notice this trend, you can catch it early so it never goes down to a lot. And that is exactly what you use a BMS for. Because if stuff hits the fan and you were sitting on the BMS and you didn't notice, then it's kind of your fault, right? So yeah, the BMS is very important. I'm learning more and more about it, but that's the basicality of it. Hope you enjoyed this. Catch you on the next one.